So hello everyone, welcome to my YouTube channel. It's me Apurv Gaurav, and today's my topic is dynamic programming of ADA, analysis of design and algorithm. So let's begin. So dynamic programming. What is dynamic programming? Welcome to our presentation on dynamic programming. We will explore its core concepts, key techniques, and practical applications in algorithm design. What is dynamic programming? Optimization technique. DP solves complex problems with overlapping subproblems efficiently. Divide and conquer plus. It combines divide and conquer with memorization for speed. Algorithm foundation. Code to algorithms like Dijkstra and Belbenford. Breaking down the name. Dynamic programming. So what is the meaning of dynamic? Refers to multi-stage decision process, a term coined by Richard Bellman. Programming signifies planning or tabulation, not necessarily computer code. Bottom up tabulation. First, solve small first, second, store result, third, build solution. So, by begin the solving the simplest subproblems, store results, save result in a table like an array or matrix. And in build solutions, construct larger problem solutions from stored results. So, the Fibonacci series or sequence calculates F0, F1, and F2 using F0 storing each results. Top-down memoization. Breakdown. Solve the overall problem by recursively breaking it down. Store in memo. Store sub-problem result in cache or memo. Check before solve. F5 needs R3 and F4 R3 is computed once and stored. If F4 also needs F3, it retrieves the stored value. Example Fibonacci sequence, recursion, and dynamic programming. So in naive recursion, time complexity is exponential, O2 power n many rewritten calculations, and in dynamic programming achieves linear time. Owen eliminates recomputation. Bottom-up approach apricity builds result in an array. Top-down uses recursion to memo to cache results. Example knapsack problem. Maximize value. Fill a knapsack with items to get max value within weight limit. Define subproblems. The problem's optimal solution depends on optimal solution to its subproblem. Build table. A table tracks the maximum value of each weight capacity and then subset. Define subproblems. The problem's optimal solution depends on optional solution to its subproblem. Conclusion. Powerful optimization, two approaches, practice key. So in powerful optimization, the the optimization becomes more efficiently. Two approaches, bottom up tabulation and top down memorization, are complementary. Practice is key. Understanding and inconsistent practice lead to mattery. Next steps. Next steps. First, review concepts. Second, practice problem. And third, explore resources. So we will discuss in briefly. So in first, review concepts. Revisit the core principles of dynamic programming. Second, practice problems. Solve diverse problem to reinforce your understanding. Third, explore resources. Utilize online course books and coding platforms. Conclusions. Powerful optimization. Powerful tool to optimize problem efficiently. Two approaches, bottom-up tabulation and top-down memorization, are complementary. Practice is key. Understanding and inconsistent practice leads to mastery. For example, knapsack problem, maximize value, define sub-problems, build table. Fibonacci sequences also is a part of a dynamic programming which includes naive recursion and the dynamic programming some code functionalities. Top-down memorization, which includes three steps: breakdown, store in memo, check before solve. Bottom-up, which means tabulation. First, solve small first. Second, store results. Third, build solutions. Breaking down the name, which already we have discussed what is dynamic and what is programming. So, what is dynamic refers to a multi-state decision process, a term coined by Richard Bellman, and the programming signifies planning or tabulation, not necessarily computer code. So, and what is dynamic programming, which includes like 3 points: optimization technique, divide and conquer, and algorithm foundation, which builds on powerful dynamic programming principles. So it's our final PPT. Thank you.